Every second of the day, we produce huge amounts of CO2. The reason for this production is our need for heat and electricity for goods and for mobility. Man-made anthropogenic CO2 emissions have been increasing every year since the beginning of industrialization. In 2018 alone, 37.14 billion tons of CO2 were emitted. This is roughly equivalent to the weight of all people on Earth multiplied by 80. But what is the problem with CO2? As a greenhouse gas, it causes warming of the atmosphere and, most likely, a change in the climate of our planet. Such climate change is associated with extreme weather phenomena like droughts, storms, or floods. Long-term consequences, such as the spread of deserts and the rise in sea level, can already be observed. All of this represents some of the greatest challenges for us in the coming decades and centuries. Besides the generation of electricity and energy, industrial processes, land use changes, and other areas, the transport sector is the third largest emitter of CO2. Approximately 2 to 3% of it is caused by air transport. While alternatives to fossil fuels already exist in other transport sectors, air transport still depends on kerosene. This fuel has the property of remaining liquid down to at least minus 60 degrees Celsius ambient air temperature, typical for normal cruising altitudes. It also has a high energy density, so that relatively little volume is required. However, crude oil is needed to produce kerosene, and as we know, this resource is limited on Earth and will not be available forever. In fact, we are facing a serious dilemma. On the one hand, we have the human need for mobility, while on the other, there is the need to reduce our CO2 emissions. CAPHENIA is fully aware of this conflict and is committed to this issue. It focuses on finding the most ecologically efficient way to meet people's need for mobility. Together with most airlines, it supports the ambitious goal of IATA, the World Association of Airlines. Accordingly, global growth in air traffic will be CO2 neutral from 2020. To achieve this goal, airlines are working on three main goals: increasing efficiency, investing in modern, low-emission fleets, and developing alternative technologies. In this third aspect, CAPHENIA is taking an innovative and pioneering path to reduce CO2 emissions. The basic idea is as simple as it is revolutionary. Is it possible to make sensible use of the carbon dioxide emitted worldwide and ultimately use it as fuel? It is possible through the novel CAPHENIA process. Imagine CO2 being captured from power stations or industrial plants and converted into synthetic fuels such as petrol, diesel, and also kerosene. To produce these synthetic fuels, additional hydrogen or H2 is needed. Normally, this hydrogen is obtained by electrolysis of water. However, this process is very energy intensive and expensive. So, is there an alternative to electrolysis to produce sufficient quantities of hydrogen to convert CO2 into fuel? There is an alternative, and it is called methane, or CH4. But how does this process work in detail? The transformation can be done in 3 steps. In the first step, the methane is put into a CH4 converter and broken down into carbon and hydrogen by heat. In the second step, The still hot carbon is fed into a CO2 converter with carbon dioxide CO2. At high temperatures, the carbon reacts with the carbon dioxide to form carbon monoxide. In the last step, the carbon monoxide is placed in a CO2 converter, a Fischer-Tropsch system, and combined with hydrogen. This so-called syngas can be converted via a catalytic process into synthetic fuel and water. None of this is a secret. The single sub-processes are all known, at least theoretically, while the last step of the process has already been implemented on an industrial scale. So what is new about it? It's the combination. So far, nobody has combined the individual steps. This creates a completely new process. But so much for theory. In practice, we still have to show how a so-called CH4 and CO2 converter can be implemented. In particular, the energetic combination of both processes represents a major technical challenge. CAPHENIA is working intensively on the development of a complete plant to produce synthetic fuel in the relevant and required quantities. CAPHENIA is pursuing this major goal with tremendous commitment in order to create a serious alternative to pure fossil fuels like gasoline, diesel, and kerosene without oil. Another positive effect is that the anticipated production cost of the fuel is significantly lower than using conventional methods. But ultimately, this new technology will achieve one thing above all else. Man-made CO2 emissions will decrease a little more with each new plant.